suppose the cart has a mass of 1.5 kgs traveling at 0.5 meters per second at t equals 0. What is the position of the cart at t equals 3? So this question is going to combine chapter 2 kinematics, linear kinematics, with chapter 5 Newton's laws, chapter 4 and 5 Newton's laws. So I asked myself, did I give you enough information to figure out the net force? I did. So the first thing I want to do is calculate the weight force. Oh, yeah, that's a good point. Okay, I'm going to keep out my own way here. Get up my Excel file. Okay, so the first thing I did is calculate the weight. Okay, so the weight equals 1.5 kgs times 9.8, and that's 14.7 newtons. Okay. Did I do this right? Oh yeah, this 10.5 might be right. So 14.7 newtons, no problems there. So we can see that the normal is equal to half of that. Not only is the normal equal to half of that, the y component of the tension is equal to half of that, and the x component of the tension is also equal to half of that, because they're all 3 boxes big and it's 6 boxes. Does that make sense? So the normal is equal to half of the 14.7. Not really relevant. 7.35. Is it not relevant? Because we're really looking for the x component of the tension, which is the same size, since it's perfectly a 45-degree angle, it's the same size as this one. So the tension x is also 7.35 newtons. So the acceleration of the cart that's actually equal to net force, so this is equal to F net on F net x, and we're only considering the net force in the x direction. Okay. So that should be 7.35 newtons divided by the mass of the cart. So I think that's where I messed up. So should end up with 4.9. All nodding in agreement. Okay, so 4.9. So that's the acceleration of the cart. It's pretty fast. I probably didn't think about my values too carefully, but that's half of a g. But let's keep going. So the delta x. So now we know it's assuming it's pulled at the same rate all the time over these 3 seconds. The delta x should be VIT plus 1/2 AT squared. And did I get this right? Okay. So I'm getting a much bigger value. So 0.5 times 3. So that's half times the time, half meter per second times the initial time, plus 1/2 again, 0.5, the acceleration, 4.9, and then 3 squared is 9. So I'm actually getting it to be 23.6. So that would be the displacement. So like I said, I didn't give you enough information to find the position because I didn't give you the initial position of the cart. So I should have said, like, suppose the cart is traveling at 0.5 meters per second and it's located at x equals 5 meters, and then you would add that to, this is only gives you the delta x, the change in the position. So I would have had to give you the initial position to find the final position, because this is only giving you the change. Any questions? Did you figure out where the 10.5 came from? Oh, it's 3 newtons. Oh, okay. That's fair. Yeah, but so you have to convert the scale. So 6 boxes is 14.7. You can scale it then.